Okay, good morning. We'll see today complete the engine. I just wanted to complete the engine part. So we were talking about SA engine, mapping, closed loop control, air control, and also finally looked into what you call feed forward with feedback to control air field ratio. Why we need both this, especially if you are working with closed loop control. Closed loop control, generally the airfield ratio, this is a closed loop airfield ratio control, which we are discussed for the last 2 or 3 days, because using EEGO sensor, correct? And if you know, if you have done a course in control system, correct? Definitely, most of you have done, correct? Closed loop control system, the easiest way to closed loop control is using PID controller, correct? Using PID controller or PI controller or PD controller. These are simply just P controller. All these controllers are called as uh, linear system controller. Correct? Linear system controller, or sometimes they call it classical controller. Classical controller is this one, but basically why it is called linear controller means if because if system under control, if the system under control has linear input output characteristics or behavioral system is linear in nature, correct? So other way around, if the model of the system is linear in nature, correct? You know, linear equation, non-linear equation, that's what we are talking, correct? If linear in nature, or the which means that transfer function is linear, transfer TF I say is linear, then only you can use PID controller, correct? So PID controller provides better performance or good performance only when system which it is going to control is linear in nature, correct? If system is highly non-linear, especially when it is system behavior highly input output highly non-linear, then the closed loop control PID will not be really very useful. It will control, but it will not be able to control the system as demanded by the user or set point, correct? So if you talk about closed loop control, later definitely we'll see somewhere, correct? You have controller, this is the controller, which I say that PID control, for example, the controller output is given to the system, correct? In this case, what is the system? In this case, you take engine, correct? Engine, what you are want to control engine? Air fuel ratio, AFR ratio, wanted to control, AFR control, correct? So how you are controlling? By controlling the air fuel ratio, that is fuel injected, correct? Fuel injected is controlled by opening and closing the injector period of pulse width duration. So that is the who is generated the pulse width. The pulse width is this is generated PWM pulse by the controller, correct? Being a closed loop, we need to measure the airfield ratio. We are trying to control airfield ratio control, correct? So airfield has to be measured. For that, we are using EEGO sensor. EEGO sensor, which is in the feedback. This is the exhaust gas going out, in which I put my sensor, correct? I put my sensor, which is nothing EEGO sensor. That sensor measures and the actual airfield ratio of the exhaust gas. That in turn will be compared with the set point, correct? In your ECU, this is called as error amplifier. In closed loop control, the circle with buck sign, correct? This is called as error amplifier, correct? It's called the error amplifier. Here is your set point. What I wanted to say, SP, or we can say the reference point, correct? Reference or set point is nothing but what airfield ratio you want. I want airfield ratio 14:1 to maintain a stoichiometry. That will be set here. That is given as input for the error amplifier, which is a plus sign. Correct? Then the EEGO sensor measures, the sensor measure actual airfield ratio of the exhaust gas. Correct? That is given as a minus. Correct? So this is a actual airfield ratio. Correct? So now here the output of this one is called error. What is error here? Error equal to set point minus actual. Correct? So that is what coming here. This error is given to the controller. Correct? The output of error amplifier is given as an input to the controller. Correct? The controller, what it does is, if control says, because we to think that this controller is a P controller, simple proportional controller, P controller. Correct? Proportional controller is nothing but an amplifier. Proportional controller is the simplest closed loop controller, a classical controller, which is called P controller or proportional controller. The controller has a gain, which is called Kp. Correct? Gain of the controller is generally represented K subscript P. Correct? So that means generally I can represent my proportional controller like an amplifier. Correct? It has a Kp. Correct? I give input. This is my output. Correct? So if I give some input, say for example, Kp is a gain, means is a mere number, correct? A numerical result. You can give gain greater than 0. You cannot give gain equal to 0 or less than 0, minus value. Your gain is always positive number, correct? So gain can be anything greater than 0. It can be 0.1, 0.2, 0.5, 100, 1,000, million, infinity. You can set infinity also. It is a positive value. So like for example, Kp equal to 10, I said. Sorry. If I said Kp equal to 10, and if I give an input value of say 0.5, for example, what will be my output? The output will be equal to the Kp multiplied by the output equal to Kp multiplied by input. So it is going to be 10 multiplied by 0.5. The output will be 5. Correct? So now if input is varying 0 to 1, correct? What will happen? If input is varying from 0 to 1, correct? Then the output will vary 0 to 10. Correct? So what the proportional controller says, it amplifies the input signal and multiplies by a factor which is called as a proportional controller gain. Correct? That will be given as an output, and where it goes, the output of this is going to control the actuator. Fuel injector is an actuator. Correct? So by opening and closing, here, what will do? The pulse width duration will be increase or decrease. Correct? Pulse width duration will be varied from, for example, 0 to say 5 milliseconds. Maximum value. Okay. So that means the I said injector opening duration. It depends upon the airfield ratio what you wanted to maintain, set point. So the controller based on the input error multiply 10 times. Correct? Now, if I wanted to control so each time when injection pulse comes, correct? We know that. Let me have one additional. Yep. Just 1 minute. Sorry. One minute. I think I touches the touch screen. It has changed to. Okay. Sorry. Okay, we'll go ahead. Now, we are talking about proportional controller, correct? We will do, depending upon the set point, correct? Set point, you are going to vary the airfield ratio. You want your engine to run from 12 is to 1 if you want to accelerate, correct? This is a rich airfield ratio. If you wanted to maintain, because driving condition, generally, depending upon the driving condition, correct? It is called drivability, correct? In engines or vehicles, it is called drivability. Drivability is nothing but, right? That is the throttle opening and throttle opening rate or closing. Both you are doing, correct? Closing rate, correct? So you are, when you are driving your vehicle, for example, motorcycle or a scooter or this one, you depending on a traffic flow, correct? If your road is empty, you will try to accelerate. If you want to overtake, you will accelerate. Suddenly you see something, you decelerate, correct? When you wanted to accelerate, vehicle should accelerate at its best. Similarly, when you decelerate, the engine should come down quickly. So how the engine accelerate or decelerate? By controlling the fuel pulse width, correct? By controlling the fuel pulse width, correct? That's what the ECU is doing here, correct? So this pulse width is varied by the ECU. Here in ECU, what is that unit? It is the controller is going to do. How the controller decides the amount of the fuel, that depends upon the set point, correct? You set the set point, already the controller knows, already you have algorithm, correct? Inside your ECU, you have airfield ratios, mass of the air divided by mass of the fuel. This is already available, correct? So the sensor, using sensors, correct, various sensor like a TPS sensor or a manifold absolute pressure sensor, or using manifold um, mass airflow sensor, correct? Mass airflow sensor, it can measure amount of the air went inside the cylinder, correct? Inside the cylinder, trapped in the suction stroke. That is sense, that information comes to ECU. ECU instantaneously calculates the fuel injection, because you give this is set point, correct? Airfield ratio is set point, correct? For the closed loop controller, this controller. For this controller, you are setting the airfield ratio depending on how this is set, correct? This airfield ratio also not constant. The set point also not constant. The set point also not constant. It is varying depending upon the throttle position, correct? So this is the closed loop airfield ratio control of the engine, correct? So set point, I say that my airfield ratio, I can vary from 12 is to 1 to, for example, 18 is to 1, correct? It varies. How we know that the throttle, when you want to run the throttle, the airfield ratio will vary, correct? So for example, mid throttle condition. So this is the mid throttle condition. That is nothing but vehicle travel from 40 to say 60 kilometer, correct? So lesser than that, correct? This is low throttle, correct? This is the mid throttle, correct? 60 or 70 kilometer. I am talking about scooter. So maximum is it goes to 100 kilometer. This is not a full throttle condition, high throttle, correct? Full throttle, correct? If somebody is putting a full throttle, 60% to 70% throttle, 40 to 60% throttle is called mid throttle. This is called as cruising condition. This is called as cruising condition in most of the vehicle. If you see your speedometer of the vehicle, correct? You will have the this one 0 to 120 kilometer, for example, in a scooter. Speedometer shows most of them, even 140 also put, scooter will not go up to that speed, correct? Most of the time 100 or 110 something. That doesn't matter, correct? So now you will see that from 40 kilometers, some say 60 something, correct? 40, 60, they put a green color, this one, paint, correct? So they mark with the green color. In the speedometer, you'll see that there are two, this one. If you run your motorcycle at this speed, correct? Drive your motorcycle at this speed, this is called a fuel efficient mode or cruising mode. Or this is called mid throttle condition, cruising, correct? That time, the airfield ratio generally maintain lean condition. Lean means maybe around 15 to 16, correct? 16 is to 1. This is the airfield ratio, where already I told you, maximum thermal efficiency, correct? All the fuel is burned, correct? All the fuel is burned, no fuel is wasted, correct? Because the airfield ratio is lean. That means you are not injecting too much fuel. You are putting appropriate fuel so that all the fuel is burn, and it is converted to hot gas, which pushes down the piston, converted to torque. So thermal efficiency more, you get maximum torque, correct? Less pollution, all those things. But sometimes, as you told you, that when you run this kind of lean, this one, if you remember some 3-4 classes, the NYX may be more, correct? We know that when the combustion is better, correct? Combustion is better when around 15 to 16, around 15.2, 15.3 is to 1 air-fuel ratio. That is slightly lean mixture. The thermal efficiency is maximum. That means all the fuel is burned, correct? In that case, the combustion temperature goes beyond 1200 degree, correct? Centigrade inside the combustion chamber. But higher the in a thermal machine, correct? If you burn all the fuel, if you get higher the temperature, correct? In this inside the combustion chamber, correct? So here the fuel is burning, correct? If the temperature is higher, correct? Higher the temperature, correct? More will be the pressure acting down. Pressure will be acting down, pushing the piston down. Then which will connect to torque. You will get more torque, correct? So thermal efficiency more, that means temperature is more, all the fuel burned. But when that case, you get more torque, everything advantage, except you have to only thing is NOx, NOx, nitric oxide. Nitric generally, as I told you, that it is created more when combustion temperature above, approximately exact number is above around 1200, 1100 to 1300, that range, correct? If it is above that, more is there. That happens in the lean air fuel emission. Now, when we are talking about this one, I told you this is the e-geo sensor. This is closed loop control. This is exhaust gas, correct? Exhaust gas. This is the engine. This is my controller. Controller, correct? Controller gives injection pulse width. It varies the pulse width depending upon the set point, correct? Set point. This is the actual air fuel ratio. Actual AFR. This is set AFR, correct? But this set air fuel ratio is not constant. That's what I want to say. The set air fuel ratio in vehicle is not constant. That depends upon which throttle condition you are operating. If you are at a low throttle condition, generally it will be slightly rich. Low throttle condition, slightly rich air fuel. It's not 14.7. In cruising condition, generally it will maintain 14.7 or many times, as I told you, it will be around 15 to 16:1, correct? Mid throttle condition. So here, slightly rich. Correct? Slightly rich, how much? You will not come to 10:1 and all. Maybe 12:1, 13:1. Correct? So if you're trying to make too much rich, you are wasting some fuel. Correct? So your fuel efficiency will come down. So your vehicle will have what you call a mileage. Correct? Mileage. Mileage you won't get because some amount of fuel is wasted. Generally, it will be 13.5, 13, 14, 14.5, something like that. Correct? So it may go up to 14.7 something. Correct? So in cruising condition, when vehicle is operating around 40 to 60 kilometer speed, correct? So the throttle open at 40 to 50% or 60%, that is called mid throttle condition, which is called cruising condition. That's how you operate. Okay. So we saw this. Then next thing is I wanted to see that spark time also need to be controlled. Correct? In SI engine, in SI engine or gasoline engine, petrol engine, correct? There are two control inputs. Correct? One is spark timing, other one is the air fuel ratio. Correct? What is that you wanted to control? You are trying to control amount of the torque produced by engine. Amount of the torque produced by engine. That's what you are going to control. If I get more torque, my vehicle will accelerate faster. If I get less torque, it will decelerate. Correct? So vehicle is driven by engine. What is engine output? It is torque. Correct? Depending upon the torque, the friction, correct? If the torque produced by engine is sufficient to overcome the engine, this one gearbox friction, correct? There are friction through the drive chain, correct? Starting from engine. Piston is moving inside the cylinder. There's the touching valve. You put lubricant, correct? You mix oil as a lubricant engine. In spite of that, we wanted to have less friction as well, but you cannot make it. Correct? Still there will be some amount of friction. Then there's a gear, crankshaft, moving parts touching with each other, gearbox, transmission, all those things, there's a friction. If this friction, your engine friction is sufficient more than to overcome this one, then crankshaft rotates. Correct? How much it rotates? The acceleration of this crankshaft, correct? Alpha, correct? So theta is the rotation, correct? Angular displacement, and omega is angular velocity, and alpha is angular acceleration, correct? So basically, we are interested in how much acceleration the crankshaft will rotate, which is in turn connected to wheels. So wheels are rotating. So vehicle is accelerating. So that depends upon the torque produced. The torque produced by engine is controlled in, if it is SI engine, there are two control parameters. One is air fuel ratio control, other one is spark timing control. If it is diesel engine, only fuel injection duration. Okay, but in case of SI engine, spark timing also. In spark time, apart from so controlling air fuel ratio, you have to control the spark timing also, correct? So this graph shows how the spark can be controlled. Already I showed you a map also, correct? To open loop N alpha method. If you remember, I showed one this one, spark timing, which I did for my scooter engine, correct? You need to generate two sets of map. One is fuel map, other one is spark timing. Please note that same speed, correct? 2,500, 3,000, 4,000, 5% throttle, 10% to up to 10%. Same condition you have to create, correct? Then one to one, correct? There are two maps. Both maps will be, one is for controlling the spark timing, other one is fuel map, and your generally I did together, correct? So this should be stored based on the open loop control. Closed loop control, you will be doing what you call as EGO sensor. Similarly, spark timing also can be controlled to control what is called knocking, correct? Knocking happens in knocking is nothing but unwanted combustion, sudden combustion inside the combustion chamber. If all the fuels are burned at a time, then high pressure will be created inside that. Then sudden high pressure will make the piston to move down. Piston cannot move instantaneously because it has an inertia, flywheel, all those things. Because of that, the pressure wave, correct? If you have the cylinder in which you have the piston which is connected to crankshaft and rotates, the piston motion cannot if all the fuel inside the combustion chamber burns instantaneously, correct? Instantaneously, that is not very short duration. Instantaneous means zero. Nothing can happen in the universe in zero time, correct? So that can maybe in the order of microsecond, milliseconds, very short duration, correct? If you have within 1 millisecond, 2, all the fuel, very high pressure is created. Very high pressure is created inside the combustion chamber. That will try to push the piston very fast down. But being system, piston having a mass, flywheel is connected to the crankshaft, flywheel, vehicle, all those things. So you cannot suddenly accelerate, push down. Then what will happen? This pressure will act as sideways also. Sideways nothing but cylinder. So cylinder will start vibrating, correct? Cylinder will start vibrating, correct? When cylinder starts vibrating, it will produce a rattling noise, right? It is, but this is unwanted. Please note that it is unwanted, correct? Rattling noise. That noise is called knocking, correct? It is called as knocking. You know, somebody, in boxing, correct? In boxing, people say he knocked down the opponent, correct? What do you mean? Sudden force, he hit the opponent with his fist on face or something. That is called knocking, no? Suddenly hitting somebody with very high force, short duration. So similarly, the high pressure hot gas created inside the combustion chamber when all the fuel suddenly burns, various reasons. Because we don't have time. Because I teach engine electronics, engine control system also, but we don't have time for that. Okay, so that happens when you use bad fuel, correct? So adulterated fuel, correct, or carbon deposit inside the cylinder, all this thing happens. Then instead of the combustion happening from the shop, starting from one place where near the spark plug, then flame has to propagate, correct? You give a spark near the spark plug, the air fuel just start burning, combustion starts. Then as I told you, this is like this, correct? This is your piston, correct? And you have a spark plug. When the spark is given, first air fuel burns here. From here, layer by layer, the fuel start burning. This is called as flame front. Flame front. The flame front is start moving towards this, starting from this one. So that means fuel air is burning orderly manner. In good combustion, the fumes, the petrol air mixture should start burning this place, and as they flame this one, the orderly manner, then pressure also increases linear, correct? So in the inside compression, correct, this is compression stroke. Here I am giving a spark, then the combustion happens, pressure increases and downs, because this is the power store, correct? This is the, here you have suction, correct? This is the compression store. Compressor, end of the compressor, you're giving a spark. Spark is given. So combustion happens. So that time the pressure is created, this will be, flame is propagating, correct? That takes some milliseconds. Few it depends upon engine speed, correct? Engine speed, all those things. It is almost close to some constant depending air-fuel ratio, internal compression ratio, many parameters. So where the flame front start moving, combustion happen linearly. Instead of that, suppose you have a hot spot, correct? I can show there's some carbon deposit there in the inside the piston, top of the piston, or inside, on top of the cylinder cover, internal to combustion chamber, correct? No, in the previous this one, when the combustion happening, if the carbon, then there will be some amount of heat will be stored inside the carbon deposits. They will be glowing, correct? Now, next time when new fresh air comes, correct? Even before you give this spark, even if you give this spark, the fuel will be ignited because the carbon deposits are glowing with hot condition, correct? Because they absorb some amount of the fuel in the previous this one. When the fuel is there, they will burn it, correct? These carbons are burning with high temperature, around 1000 to this one. So when fresh air-fuel ratio comes during suction, correct? Nothing will happen. During compression, because valve is closed, when the compression is there, by the time the fuel has mixed and the combustion will start here, combustion will start here, combustion will start here, combustion will start here, even before you give the spark. Correct? That means without giving spark, the combustion in the SI engine happens because of carbon deposits. Correct? That's why you have to regularly remove the carbon particle inside your combustion chamber. This is called decarbonation. Mechanic will say that it is called decarbonation. Correct? So this is called unwanted combustion. Correct? Unwanted combustion. Because of that, because multiple places the combustion started, flame will start from the propagate inside the combustion. So instead of starting from this one, spark plug, correct? One place, and linearly it is propagating combustion, smooth combustion, which takes few milliseconds. Multiple place, flame will start from. That means all the fuel will be inside the combustion chamber, will be burned quickly. I mean, very short duration, within 1 millisecond, 2 milliseconds. So then very high pressure is created, then which makes the engine to vibrate. Correct? So that is called a knocking. If you allow the engine to run in knocking condition, your engine itself can break into pieces. Correct? So you should not operate your vehicle on knocking condition. Okay? That is one thing. Okay. Now we'll go to, so speed, idle speed also can be controlled. Correct? And the spark timing also you have to control. Correct? You can control the torque produced by engine by controlling spark timing and air-fuel ratio. Okay, just keep it because there is a big area. So this is what I told you. When engine is running smoothly, correct? If there's no knocking, you can see that engine inside pressure. Correct. This is TDC. This is the this is nothing but compression store. Correct. So it goes smoothly. Correct. So you are giving you are giving somewhere here. Yeah, giving spark. Okay. Now, if there's a knocking happen, you can see that this is a pressure wave. Using a pressure sensor. You put a pressure sensor on the combustion chamber. Combustion chamber, correct? Combustion chamber pressure. So if there's no knocking, it will be like this. If there's a knocking, you can see that there you can see a light knocking condition. You can see that there's a pressure wave. If like heavy knocking, you can see that this is this high pressure wave. Correct? You see the pressure is varying. It's not constant. It is not constant smooth. Correct? So because of that, what happens? You can see that there's a pressure wave. This will rattle the engine, rattle the cylinder and piston. Correct? Engine is cylinder the main part. Correct? The rattling is moving violently. Correct? Because of that, when it moves violently, there is a stresses happening in the cylinder. All those things, cylinder can break. Engine itself can break if you operate under this one. Apart from that, it will make a violent noise. Correct? Because any vibration is nothing but pressure wave, no sound waves. when something is moving in the air, it creates sound. Correct. So it can be sensed with the different type of sensor. That's what is shown here. By measuring the in-cylinder pressure, you can see that there's a knocking. This is light knocking. This is heavy knocking. Correct. Here there's no knocking. This is good. But one more thing also I just want to tell you. If you run engine, this light knocking condition, very, very, very important. Correct. Very light. Correct. Because you can see the very small this one. If you run your engine close to knocking condition, correct, it gives higher thermal efficiency. But you should not run on heavy knocking, very light knocking, close to I can say that close to knocking or very light knocking. Correct. If you run your engine, you will get highest thermal efficiency. That's good. Correct. Too much knocking means it will break the engine. It is vibration, stress, all those things. This one. So how you can control in SI engine? Knocking can be controlled by advancing the or retarding the spark timing. Correct. Spark timing, using spark timing, you can advance or retard. Thereby you can see that the engine is running close to knocking it. So again, that is a closed loop control. Closed loop control of spark timing. To control, see that engine runs close to the knocking condition or light knocking, not at heavy knocking. So what you do that, you have to put additional sensor in the this one, like EGO sensor. Correct. EGO sensor is used for air-fuel ratio measurement. Correct. NOx sensor. This is used for air-fuel ratio control. Correct. NOx sensor can be used to. You have to install NOx sensor over the engine. Correct. Which can measure the vibration. So you can use accelerometer. Correct. So there are three different type of NOx sensor are there. One is called by measuring sound intensity. So using microphone, you can use microphone. Correct. Near the engine footer, a microphone cannot withstand high temperature. In laboratory, you can do it, maybe be a little far away. In actual engine, nobody uses a microphone. So you can see that whenever knocking is there, engine is vibrating. You will hear the sound, knocking condition. For example, if you are a new learner for motorcycle or car, correct? Correct. If you are a new learner to motorcycle, if you don't change the gears properly, correct? For example, you are traveling, correct? You put first gear and started moving up to 10 kilometers. Once you cross 10 kilometers, you generally go to second gear. Like, so you go to say four gears in your motorcycle, correct? So you go to fourth gear at approximately 35 to 40 kilometers up to 100 kilometers speed, correct? Top gear, for example, correct? So now, while you are going at 40 kilometers, you go to the fourth gear, suddenly somebody appears in front of you. What do you do? If you're a new learner, immediately apply brake, correct? Generally, what do you do? Immediately you apply a brake. You apply a brake, vehicle speed has come down to say 20 kilometers, correct? The obstacle in front of you moved away. Correct, some animal, something, whatever it may be. You are watching. So what you do? Immediately you try to accelerate. Correct, without changing gear. Correct, without changing gear. If you accelerate, you will see that engine will make a lot of noise and then jerky movement, and the vehicle will stop. If you are new learner of motor, any vehicle, whether two-wheeler, four-wheeler, you will notice that. Correct. So what happens is, if you apply brake, vehicle speed will come down. Your gear is in fourth gear. If you are in fourth gear, engine doesn't produce sufficient torque because you have removed the throttle also. Because you apply brake, you reduce the throttle also. Engine is in fourth gear. In fourth gear, the torque produces not sufficient. Correct. So that means if you try to get more torque, because vehicle is not moving. So what you are doing, if you more torque, what is natural tendency? Press the accelerator. That's what I told you. You get more torque by injecting more fuel. So you will press the accelerator pedal. So you think that you are injecting more fuel, the engine will accelerate. No, correct? That condition, what happens is engine speed already low, the air fuel ratio, all these things are not with proper condition. It doesn't give proper combustion, correct? Fuel resistance, engine is not producing torque. So best thing is reduce the gear, correct? You reduce the gear, maybe second gear again. Then if you try to accelerate, then vehicle will start accelerating. If you don't reduce the acceleration gear, correct, from fourth gear to second gear something, you will see the engine making noise. That means you will see a lot of heavy, as the engine inside there something is happening, correct? Huge noise, explosion, something, vibration, all this thing. That is nothing but knocking. If you drive your vehicle like that, correct, frequently, without changing gear frequently, your engine can, in fact, can be broken into pieces. It can crack, can happen. It not have a main this one. Slowly, stress will happen. Engine block can crack. So then you have to replace the engine itself. Apart from that, crankshaft also will be under tremendous pressure. All moving parts inside the engine will be under tremendous crankshaft, correct? Connecting rod, piston, engine block, everything because of heavy vibration. So what you have to do? You have to reduce the gear and then you have to start accelerating. But when if you're a new driver, you cannot coordinate all this thing. This will happen, don't worry. But try to avoid. This is what knocking condition. So knocking condition can be by measuring sound vibration, correct? Using microphone, or you can use in cylinder pressure sensor. In cylinder pressure sensor. Correct. What they do is, if you are ICE engine, if you go to ICE engine lab, research students you will act with. So here you have the spark plug. Correct. Here you have, for example, fuel injector, injecting fuel. This is my exhaust. Somewhere here they put, they make a hole in the cylinder head. Correct. Because this spark plug already company made a hole. Correct. There's a thread. You have put this injector company made. Correct. So if you want to measure in cylinder, you have to make a hole, and this is your in cylinder pressure sensor. Generally, it will be piezoelectric pressure sensor. Pressure sensor, correct? We know that the pressure can go up to 70 to 80, 70 bar something, 80 bar, correct? Diesel engine can go higher also, correct? So depending on petrol and all this thing, so the sensor measure that this is what the pressure. As the piston is going up, the pressure increases. It goes to, you give a spark here, correct? And you give a spark here, combustion happens, it reaches, this is called peak pressure. That varies depending on the petrol, diesel engine, compressor, or what is this cylinder capacity, all those things. Okay, so you can measure. So if there is no this one knocking condition, you will see a smooth this one, correct? Pressure signal. If there is a light knocking is there, apart from the pressure signal, see same only, pressure signal not different, because knocking happens here, correct? Heavy knocking procedure. The third one is using washer type pressure sensor, because you know that the engine top cover, correct? Cylinder head, we call it a cylinder head. Cylinder head will be connected to the cylinder through 4 bolts, correct? And there they're using was, instead of that you will use washer type pressure. This just to this how you know. So knocking can be controlled by changing the spark timing, correct? When the spark is given. That is called advancing or retarding the spark. So yeah, here it is. Yes. Now this is the knock sensor piezoelectric washer type. You can see that through which there's a, this is this one. You will put a nut. Correct. So this is the cylinder head. Correct. You will see that this is coming out. There's a general nut. You remove this nut and put this washer type cylinder. There's a hole. Correct. So it looks like a washer between. This is the cylinder head and this is the bolt. In between, generally put a washer, spring washer or something. Instead of that, you can replace this sensor. It consists of multiple layers of piezoelectric. These are piezoelectric wafers, correct? They are connected to out. When the piezoelectric wafer, if you apply a pressure, they produce electric charge. Correct? The charge, that's what is shown here. The charge can be given to an amplifier. If the more pressure is there, correct? So when there's no knocking, correct? There's a no pressure. When there's a light knocking, you can see that the amplitude of the piezoelectric sensor vibration signal. Correct? Vibration signal, engine is vibrating. Correct? So if heavy knocking is there like this, so you can use any of this vibration, the washer type, this piezoelectric washer type sensor, or in cylinder pressure sensor, or microphone also. Microphone, you cannot put it on the engine, keep it a little away because the engines of our microphone will not withstand. This sensor can withstand up to 400 to 500 degrees centigrade. In fact, this can withstand up to this one. Of course, they'll put a what you call water cooling. Water also circulating inside the in-cylinder pressure sensor, correct? To cool this sensor, otherwise they fail. But there are now high temperature sensors are there. There's no need for cooling, correct? In-cylinder pressure. These are washer type. These are piezoelectric material, so they can withstand up to 400 degrees. Okay, there's no problem. Knock control, how will you do? Correct. Again, I told you, engine. You have the engine. Engine. You have the, just like your air field ratio control. The spark timing. Correct. The spark timing needs to be controlled with respect to, should be controlled with respect to TDC. Okay, what it means is, yeah, I will show here itself. Okay, we know that if I talk a 4-stroke engine, there's a suction stroke, then compression, you give a spark, correct? So then it goes, comes down. So this is 0° crank angle, correct? This is 180°. This is 360, 540, 720, correct? 4-stroke engine. We are talking about 4-stroke engine, petrol engine. So suction, this one, I am giving a spark here, correct? Fuel is injected here. If you pour fuel injection happens in the suction stroke. Okay, so then the compression starts. As the compression starts, the piston is moving up, the air fuel mixture is compressed. At this point, you are giving this timing is called spark timing. This is called as spark timing, correct? So spark, this is your TDC, correct? This is the maximum thing piston can go up, correct? So that is TDC. So how many degrees? Because this is start, if you take the within the, this is 180°, correct? For this, I take this is a reference for this stroke, compression stroke, correct? So as the piston is going, you are going up. Now you have to give a spark, not during the TDC. You have to give spark somewhat in advance, before some time. That time is called spark advance time with respect to TDC, correct? With respect to TDC, you are giving a spark. You can give here, you can give here, you can give here, you can give here also. Wherever you want to, you can give, correct? If you give a spark, then only combustion starts. Already fuel is mixed, that part is over. Fuel is injected. In the suction stroke, after that, no control. During the suction stroke only, you have to control the pulse width so that fuel will go inside, correct? So then, after a compressor start, means fuel is stopped because inlet valve is closed. Now, the spark in SI engine, you have to give spark. If you give spark, immediately combustion starts, correct? From the spark plug, and fuel is burning, pressure is created. Suppose what happens during this time? If I say that it is compression start when the piston is in the BDC position, correct? So compression stroke is moving up. Here you have your spark plug, correct? So this is your exhaust, this is your inlet, correct? So this is, both are closed. Compression will happen. Piston is moving up, correct? And from BDC, this is nothing but BDC. Up to where it go, it will go to TDC, correct? So already I told you this is TDC condition. This is nothing but your BDC, correct? As the piston is moving up, I can give spark. Spark can be given anytime, correct? But if I give spark while the piston just move little bit, what will happen? Compression is not fully happened, correct? So then if the already fuel are mixed, the fuel will start burning, correct? If the fuel start burning, what will happen? The pressure increases. What is the pressure will do? Because these are fixed cylinder, no, they cannot move. Only moving part this. The pressure will be applied on the piston, correct? Then the piston wanted to go up, but the combusted hot gas, because I gave the spark very advanced here, correct? Very early. I will put in another color, blue color maybe. You can see that I gave here itself. Just about the compression side, just as what you do after a few degrees. You give the combusted gas will push the piston down, but the crankshaft is pushing up because crankshaft rotation it has to go up to TDC. In between, you if it comes, you will not get power. Or correct, you will not get power. So this is pushing down. So that means you are wasting energy. The piston is moving up because of the energy stored in the flywheel, which is compressing the air fuel. But you are supposed to go up to this point, but you gave the spark in much advance. So this is pushing down. This piston is moving up. So in between, net result is you lose the power generated by the power stroke. So that means how much pressure created, how much power you will get, torque get, depends upon when the actual combustion starts and how much pressure is there. The pressure will be higher if the piston has moved close to this condition, correct? Almost close to TDC. That time the air filled mixture is already compressed. We say the compression 80:1, correct? This is called compression ratio in petrol engine. In diesel engine, you can go up to 15:1. If compression ratio is higher, correct, then if you burn the fuel in the compressed air filled mixture, then all the fuel burn, then you get highest pressure. If you get highest pressure, correct, then the more torque will be there. So that means you should not start burning fuel when the piston is going up. But only one thing is you have to, that means you should give spark somewhere here, maybe 30 degree. This is 30, say 40 to, correct? It can be, you can give somewhere here, some 40 to 20 degrees before TDC. So piston is coming up, correct? From 0, it is going up. When it comes somewhere here, you have to give spark. That is called optimal spark timing, correct? Optimal spark timing is not at the beginning of the compression stroke. It is not during the end of the compression stroke. You should give something around 30, just before the TDC, correct? In the compression stroke, maybe 30 degree before, 35 degree, 40 degree, or 20 degree. So this is called as best to this one. Why is that needed? Correct? You measure why that 30 degree, 45 degree. It varies from, for example, 20 degree to 40 degree. I am giving a typical example. Correct? With respect to TDC. Correct? So why, on what basis? That depends upon engine speed. Engine speed. Okay. Why this engine speed is important? We know that if the piston is moving up and down, correct, with some velocity, piston velocity. Piston, well, who is driving this? Crankshaft, correct? So crankshaft with flywheel, because you have big mass, correct, attached to this. So it stores energy. This is what moving piston up and down. Crank mechanism with the flywheel. Flywheel stores the energy coming from it delivers to the wheel also, correct, to drive to gearbox, but also it is moving piston up and down, except the power stroke. That is third stroke in a four-stroke engine, correct? So that why the 30 to 40 degree? If I told you, if the engine is running 3000 RPM, I talk a single cylinder petrol engine, correct? 3000 RPM. What is RPS? Divided by 60 is nothing but 50 RPS, correct? RPS. That RPS is revolution per second. So you can talk in heads also. You call 50 heads, correct? So that means within 1 second, the crankshaft rotates 50 times. When engine is running 3000 RPM, crankshaft rotates 3000 RPM minutes per revolution per minute, or 50 rotation per second, which is a 50 hertz. Now, what is cycle time? That means if you see that this happens like this: one cycle, second cycle. So this is one cycle, because this is one cycle, cycle 1, correct? This is cycle 2, cycle 3, like this. How many times within 1 second? 50 times when engine running. So if the engine is running 6000 RPM, it will be 100 times, correct? 6000 divided by 60 will be 100 RPS or 100 hertz. So 100 times the crankshaft rotates. That means within one rotation, the piston goes up around 4 times, correct? Being a 4-stroke. Okay. Now, that means the compression stroke. What is the time of the compression stroke? If engine is running, we know that it is 50 hertz. What is cycle time? Cycle time is nothing but 1 divided by the hertz, or RPS, is going to be 20 milliseconds. Then what is this divided by 4? Because it has suction stroke, compression stroke, power stroke, and this one. So the compression stroke is divided by 4, 5 milliseconds. So in the 5 milliseconds, the compression is happening, correct? The compressor start here, it is moving up, piston is moving up, correct? From BDC to TDC, it takes 5 milliseconds when engine is running this one. So now 5 milliseconds divided by 180 degree is the time for 1 degree movement of the crank, correct? So that now if I say if I say that 40 degrees maximum advance, 5 divided by 50, I can say that 500, correct? So this is, so approximately 2 point something, correct? 0.24, correct? So per degree, so many milliseconds, 0.24 milliseconds, something happens, correct? That is time is per degree movement. So multiplied by 40 will be the time needed for combustion happen. Because I told you, air fuel mixture will not burn instantaneously, correct? So the fuel start burning. I will remove unwanted things, correct? So now what I was saying is, now I give a spark here, the flame starts propagating. This is the end of the, so the fuel to burn, the air fuel mixture to burn, it needs some amount of time. Like a combustion duration, we call it as combustion duration. Combustion duration for petrol is approximately fixed. Any depending on fuel, it is fixed, correct? Approximately, but it slightly varies depending on compression ratio. What is compare 8:10, all those things, many conditions, but generally it is constant, correct? Combustion duration, correct? So it will be generally in the order of milliseconds, correct? It will be in the order of say 3 to 4 milliseconds. I am giving an example. So that means the fuel should not, you should not give spark much advance. So then combustions are early means it will oppose the movement of pressure, you will not get power. And if piston goes to TDC, after that you give a spark, correct? If you give a spark, what happens? Fuel will burn. By the time already it reach TDC, piston is start coming down on its own. Who is pulling down? The crankshaft itself is pulling the piston down, not the pressure created by the combusted air, correct? Combusted fuel air mixture, which is called exhaust, correct? The hot air is before, if you give the spark close to TDC, correct? If you give the spark close to TDC, correct? So what happens is, okay, if you give the spark close to the TDC, okay, here somewhere, correct? Spark give very close to our TDC. There's no sufficient time for the fuel air mixture, compressed fuel air is burned, correct? If fuel air is not burned fully, correct, the pressure created will be less, correct? Will be pressure created is less. If pressure creates less, you will not get power. I told you the amount of torque, correct? Amount of torque produced by the engine is proportional to the fuel burn. If fuel is burned fully, more pressure is created, correct? If more pressure is created, then piston will move down with lot of force. The gas is pushing down with lot of force. The force is converted to torque. Linear force is converted to torque. That means if you give a spark close to the TDC, correct, the piston already moved top and then it start coming down. Because I told you, air fuel mixer burns, takes some amount of time, combustion duration. If you don't give sufficient time for combustion to happen, the fuel air mixture burning will not produce sufficient pressure, downward pressure, so torque is less. So you should not give the spark much advance or very late, correct? This is much advanced, correct? Much advanced condition. The early condition, advanced or early condition. If you give, also the force will push down, it will not give more torque. Similarly, if you give spark very close to TDC, combustion will not happen. Even if it happens, already piston is start coming down. So you will not be able to extract the pressure created by the hot air because piston is moving down. So you have to give a spark somewhat some 40 degree, 20 degree, correct? The duration before TDC. That depends upon engine speed, correct? If engine is running higher speed, you have to give the spark in much advance here. Okay, I am sorry, I'm just taking a little time. So you need to, yeah. When you detail, correct? So you have to give within the region. If you have to give 40 degree before TDC, this is 20 degree before DC. The engine is running at slow speed, you give 20 degrees sufficient because piston is very slow. You have sufficient time for fuel to burn. If engine is running 6 on a higher RPM, you have to give much advance. Why? Because piston is moving fast. So because engine is running, so you have to give spark. So always you will have the constant combustion duration. The combustion duration cannot be varied. So you have to give spark. So higher RPM, engine running high speed, correct? Spark should be given advance when engine is running. So that means the spark time should be varied. It's not constant. So that's why you have to measure engine speed, correct? And also engine load also decides when to give the spark. Okay. Then based on like a fuel injection, engine speed and engine load is given as input to the ECU. Inside there's a map, correct, which you have to create like a fuel injection map. Accordingly, the engine spark will be given, correct, so that knocking can be controlled, correct. Knocking also can be controlled. That's all. I stop here. Tomorrow we'll see about next week we'll see CRD engine, correct. Then that is diesel engine. Then we will talk about other. Okay. Thank you.
Sir.
Yeah.
Sir, can you upload the lectures?
Yes, I am uploading. I told you because I was able to compress most of the things. Okay. I will put in Moodle this week and I'll send you the link.